1, 2, and 3. We are online again. All right, so now we're going to go back to question number 13. I'm going to try to just do it myself so that we can go faster, yes? A bin contains 3 reds and 4 green balls. So we have 3 reds, 1, 2, and 3, and we have 4 green. So that would be 1, 2, 3, 4. 3 balls are chosen at random. So I'm going to select 3. 1, 2, 3 with replacement. That means that I take one out and I put it back. So the probability remains the same. Remember, the 4 conditions in this case will be okay because we are replacing them. I don't want to go that again. You can look at question, what was 18 that we did? The video. All right. So in the previous videos, we have explained that. Let the random variable X be the number of green balls. So we are going to be another thing that we have to remember. This means the number of green balls. Okay. Explain why X is a binomial random variable. I think we have explained that, and the reason was we have n. That means that you're going to do this 3 times. It's fixed. It's not going to change. You're going to do it 3 times. What's the other thing? You have to have 2 answers. 2 answers. What are the 2 possible answers that we can have? Well, oh, green or no green, right? So is green or not green? Because not always, you might have different colors. So yes or no? It is the color that you want and it's not the color that you want, just to make it more general. The probabilities remain the same. Yes, probabilities are the same and they are independent. In other words, every time you do the experiment, you will have the same probabilities again and again. All right, so we wrote that. Let's go to number B. Construct a probability distribution table. And this is something that maybe I will elaborate just for the first one. Okay, it's X is the number of green ones. The probability of that happening. The table should always have these 2 things, right? The table should always have the number of greens, the probability. Is everybody okay?
Yes.
All right. So I'm going to make my table. What if I'm going to take 3 balls? What are the probabilities? What are the probabilities of the X value? I can have 0 greens, 1 green, 2 greens, 3. Can I have 4? No, because I'm only going to put my hand 3 times, right? These are the only possible answers for the experiment that I'm conducting. I'm taking it 3 times. These are the only possible answers. Questions on that one? All right. So now let's look at the probability of each one. Now this is where it becomes a little difficult. 0. What is the probability that I get 0?
0.
Why?
It's 1.
What is it? 1 means every time. If you put 1 here, that means every time you do this, you're going to be able to get it, right? 4 over 7. I'm going to do this.
0
It means, remember what X means. X means the number of green balls. So these are the only possibilities.
3 over 7.
3 over 7.
Well, I'm going to put that 3 times, right? I'm going to put
3 over 7 multiplied by 3 over... No,
Just 3 over
3 over
7.
7 multiplied by
3 over 7.
2 over 7 multiplied by... No, you should come down.
The teacher.
Okay, 3
3
over
over
7
7.
What?
multiplied by 2 over 6 multiplied by 1 over 5.
No, because these are replacements. So you still have the same probability. If you don't have the same probability, then you have a problem, right? So let's take a look at this. Let's take a look, okay? So the first time you put your hands, how many green ones do you have?
4.
it says you cannot have green ones. Sorry, you cannot have green ones. So you have what? Red. So it will be 3 over 7. The second time you put your hand inside, and you want to take something that is not green, what is it? No, it's 3 over 7. Because you are replacing them. If you were not replacing them, you would have answered no, it's not a binomial distribution. But because you're replacing it, you have those 4 conditions. Okay? And what's this third time that you put your 3 over 7? Does that make sense to you? Okay. The problem is that who said that this is the only order that you can put your hands in there?
No. Maybe you could get 4.
You can also get another way to do it, no? All right, you can have a different way to select this. Is it? Because this is the first one, this is the second, this is the third one. But you can have, this is the first one, this is the, you will have the same 3 over 7, 3 over 7, 3 over 7, and 3 over 7, 3 over 7, 3 over 7, because there are different ways to do this. If I say to you, you can, if you knock this bottle of water from that desk, then you win. And you say, how many chances do I have? 3 chances. So I'm going to give you 3 balls, and you're going to throw the ball to see if you knock it out. And you throw the first one. Did you lose? No, because you have another 2 chances, right? So can you win the first time?
Yes.
Can you win maybe the second time?
Yes.
So you can win any number of times. You can have, for example, win, lose, lose. You can have lose, win, lose, because you only want looking one. You can have lose, lose, win. No, you can have win, 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 because you can only win one time, right? If you knock it, that's it. You're not playing anymore. So you can have 3 7 3 7 3 7, or you can have 3 7 3 7 3 7, or you can have 3 7 3 7 3 7. You don't see it that much here because they are the same. So instead of doing all of this, how many 3 7s you have? Well, why don't we use the formula? Isn't this a binomial distribution? If it is a binomial distribution, you can use this formula. C combination x, p to the power of x, q, n minus x. You can use this formula to complete it. That formula can only be used if you have binomial distribution. And you can see the formula when you actually put the numbers, right? For example, look at this. What does n means? Well, n is
The number of the
n is
balls.
what?
Balls that we have.
How many balls you have? So you have, no, like how many do you want? What is it that you want? 3, right? Yeah, you want 3. What is x? This is what you want. In this case, is 0 because you're doing this one. What would be p? That's the probability of getting a green one. 4 over 7. The probability of green one is 4 over 7. P is what it's actually what the problem says. And you're missing Q.
Is like the P minus 1?
Yeah, 3 over 7, right? So now let's put it in the formula. N is what? It's 3. C 0. That's the x for this particular problem. P is 4 over 7. Power to the 0. Meaning you don't have any of this. And how many 3 or 7s you have?
3.
3 minus 0 is 3. Isn't that what?
Have any options like this?
Is it? Yes. Isn't that what we have? If you work on that.
Yes.
By the way, what's 3 combination
1.
0? 1. If you don't know this, you can use the calculator. I show you how to use the calculator. Let's use the calculator in case you forgot. Let's go to menu. Let's go to 1 and delete everything that it says there. This calculator has a button that says option. I don't know if you see it next to the yellow. And the menus on the bottom are not the menus that you want. You want to go to the next one, which is probability. What number is probability?
F3.
F3, because mine's a little bit off, right? Because it has, but if you take this off, you will be able to see it. If F3, probability is F3, so I press F3 and look what I have. 1, 2, 3. Look at the 3.
I messed it up.
I will return it because I'm recording. I'll return. So I will say 3C0. I just gonna do that one. It gives you 1, right? All right. So look at what is gonna happen. So this one is 1. What is anything raised to the 0 power? 1. So what do you have left? 3 over 7, 3 over 7, and 3 over 7. Isn't that what we had before? So it's going to be 3 times 3 times 3. 27 over, what is 7 times 7 times 7? 90? 98? Okay, 7 times 7 times 7. Okay. Well, the next problem, right? 343? Okay, somebody was, sorry. What is it?
343.
So it's 27 over 343. I'm going to write it like that because I don't have a space, but you can put it in decimals if you want to, okay? That's fine. So the next one, I don't need to do all of this. The only thing that I need to change is that the x is not going to be x, but it's going to be 1 because you're doing 1. So it's going to be 3C1. Remember, I can do this here because this is binomial distribution. How do I know? Because you're replacing. It says with replacement. So this is going to be 4 over 7, 1, right? 3 over 7, and that's going to be 3 minus 1, that is 2. Because you have 1, so you got one of these. This is the one that is the opposite of that. And then you do that in the calculator. If you don't know how to do that, you can do that in one shot. You don't need to just do one at a time. If you use the calculator, please remember, you can put decimals if you want to. If you use the calculator, don't worry about that. 3C1. You need to write, in my calculator, you need to write multiplication. 4 divided by 7. Guys, if you're going to leave, it's okay, but don't make noise. See? Thank you. And 3 divided by 7. I'm going to finish this for the people. Asgari, I'm recording, my love. So it's going to be 0.315, right? Because I'm cutting it off. I shouldn't, but for the interest of time, would be 315. And you can do the rest. I did it here. I'm going to copy. This will be 55. Sorry, not 55. Right? The next one will be 3C. And now instead of 1, it's going to be 2. This one will be 3C3. So I'm going to quickly copy this. 3 minus 2 is 1. And this is 4 over 2, 7, 3, 7, 0. So this is this is 3, right? So this is going to be 0.8396, 0.5598, and to make sure that
It has to be add to 1.
well, this is not going to add to 1
Okay, yeah.
because this is already
Replacing.
no, not only because, but this has already been this is a percentage of it, right? This is a percent. I don't think this is going to be added to 1. This is 83 and 55. So because you're combining different objects here, so this is not going to be equal to 1. The expected value means mean.
You need to multiply this.
No, it's already been done for you. The only thing you have to add all of this 4 units. If you add all of these 4, it already gives you the mean. This is a distribution tables like this. This is probability. If you add them, this only happens with binomial distribution. If you add them, it gives you 1.7143, which is the expected value.
So So we have to divide it by 4. No.
No, you don't, because it's already being, every time you did it, you divide it. You see 300? Yeah. So it's already built in. That's the beauty of this, right? How about if you don't have a table? If you don't have a table, then you have formulas for binomial distribution, which is n multiplied times p gives you the mean. If you don't have a table. If you want this, the standard deviation will be n times p times q. The square root of that will give you the standard deviation. These are formulas that I gave you. Those are formulas that don't have, when you don't have these tables, right? All right. What does the last question says? Sorry, I'm about to finish, but I want to use this. Use the law of large numbers. Law of large numbers means you keep doing this over and over and over and over again to interpret the meaning of the expected value in the context of this problem. That means that if you keep doing this over and over again, the average number of green, remember that's what we have, balls, will be 1.71, almost 2. The average will be of, if you keep playing and playing and playing this game, the average number of green balls that you will take out is almost 2.
Doesn't change.
No, I mean, the more you do it, it's going to get closer to 2. But if you do it only a couple of times, it's not going to work. It's the average. If you keep doing this over and over again, it will give you 1.7. Thank you.